guys, this is the week 8 video. Okay, so I'm going to go over a couple of the problems that you're going to see or something similar that you're going to see on the Google form for this week. So it's going to be the same layout that we did for week 7. Okay, so I'm just going to position this so that you can see it. Let's see. There we go. I think that's good. Okay, so if you notice, we're looking at rounding. So hopefully you remember your rules for rounding, and that's if it's 5 or more, we add 1 more. And if it's 4 or less, we let it rest or just keep the number the same where it says to round to, okay? So if we take a look here, we have 5 and 982 thousandths, and we want to round to the nearest tenth. So when we want to round to the nearest tenth, that means that's the place value that we're rounding to. And that means we want to look at the place value to the right. And we look at the 8, and the 8 is in the 5 or more category. So that means we are going to add 1 more to the 9. But 9 plus 1 is going to give us 10. And we know we can't put 10 in one place value. So we actually know that we're going to bring the 0 down, right? And then we're going to add 1 to the 5 to make it a 6. So this number actually rounds to 6.0 or 6 and 0 tenths. Because remember, we want to round to the tenths place. So we do want to keep that 0 there. We don't need it, but we do want to keep it there. Okay. Now let's take a look at the next one. We have 17 and 694 thousandths, and we want to round this one, though, to the nearest hundredth. So we have to go to the hundredths place, and that means we're going to look at the thousandths, the place to the right, and it is a 4. And we know that 4 or less means we let it rest or keep it the same. So we're actually going to get then 17 and 69 hundredths. And remember, when we give our numbers, these are rounded numbers. So you remember this little squiggly line. That little squiggly line means that the number is about 17 and 69 hundredths. And over here, the number is about 6 and 0 tenths. Okay, so hopefully that reminded you how to do rounding. I'm just going to pause so we can go to the next problem. Okay, so for this one, looks a little tricky, but you're trying to fill in the blanks here. You want to fill in the smaller blank with multiplication or division, and you're looking for a power of 10 for this blank. So are we multiplying or dividing by 10, 100, or 1,000 to get from this number to this number? Now these numbers look very similar. We have 61,983, and this number is very similar. Instead of a comma, it's a decimal point, okay? However, it completely changes the number. This one is 61 and 983 thousandths. So this number is a whole lot smaller than this one, even though the digits are exactly the same. Okay, this one is like having, if we were to round this to the nearest dollar, this would be like having $62, right? Because the 9 says to add 1 more. This would be like having $61,983. Obviously, we would much rather have this number, okay? So we're looking at these two sets of numbers, and we notice that the number's obviously getting smaller. So we know the operation isn't going to be multiplication, because multiplication makes the numbers get bigger. Division is what makes our numbers get smaller. So since they're the same digits, okay, we know that we are dividing by a power of 10. The decimal is only moving a little bit. So we want to figure out how many spaces the decimal is moving. So when we have a whole number, technically the decimal is at the end, right? So that decimal to get over here is actually moving once, twice, 3 times to the left to make it this number. So that means we're going to divide then by 1,000, because 1,000 has 1, 2, 3 zeros. So that means when we divide by a power of 10, we're going to move the decimal to the left 3 times. So we move it 1, 2, 3 times to the left, and now we get the current number of 61 and 983 thousandths. Okay. The next type of problem we're going to look at is order of operations. So if you remember, order of operations, I'm going to write it over to the side here, but we have please excuse my dear Aunt Sally, right? So that means we are first looking for parentheses. Second, we're looking for exponents. Third is multiplication and division, but remember they're grouped together. So we read from left to right, okay, trying to see whichever operation comes first. So if division comes before multiplication, then that's what we do. And then the last one is addition and subtraction, but again, we read from left to right. They are grouped together. Okay, so if I were to complete this problem, I have brackets and I have parentheses inside, which means I need to do the parentheses inside first so that I can finish everything that's inside the brackets. Okay, so I'm going to start with 25 minus 11, and 25 minus 11 is going to give us 14. Now remember, I like to make the pizza. I like to bring down everything because this helps me stay organized. So I still have the bracket here, plus, and I still have a set of parentheses here, and that's all in the bracket, okay? And then I'm still dividing by 5. So I still have a bracket, but now I still have parentheses inside that bracket. So I have to go with the parentheses. And 15 minus 9 is going to give us 6. But now I still have the brackets, and 14 plus the 6 here inside those brackets divided by 5. Now I have to finish out what's inside those brackets. So I'm going to do 14 plus 6, which is 20. And then bring down the 20 divided by 5. And 20 divided by 5 is going to give us a final answer of 4. Okay, and if you remember, I call this the pizza method because if you were to draw a triangle around it, it looks like a pizza. And we want just one pepperoni, which is our answer. Some helpful hints when we do order of operations. Remember, in 5th grade, you should be getting whole numbers as your answer for order of operations. You're not going to get a challenging problem where you're going to get a decimal or a fraction. So if you start getting those types of answers, go back and double check your work because it should end with a nice whole number here. Okay. Okay, the next problem that we're going to look at is quadrilaterals. So remember, quadrilaterals are any four-sided shape, but four-sided shapes have very specific properties for each of the different kinds of four-sided shapes. So if we take a look, we have quadrilaterals, and they break off. Quadrilaterals can be a trapezoid. What makes a trapezoid is that it only has one pair of parallel sides. So these two sides are parallel, meaning they will never ever touch, but these two sides are not. So they only have one pair of parallel sides, and that's what makes it a trapezoid. A trapezoid is no other shape. A trapezoid is only considered a quadrilateral. A trapezoid is by itself. Another shape that's by itself is a kite, and you don't see this one too often in 5th grade, but a kite just means that the sides that are next to each other are equal to each other. So the one tick mark, remember, means these two lines are the same length, and the double tick mark means that these two sides are the same length. So a kite just means the lines that are next to each other, the sides that are next to each other are equal. Don't worry too much about the kite. It's not too much a 5th grade skill just yet, okay? But it is a quadrilateral. Now, the rest of this is really, really important. These are super common in 5th grade, and you need to remember these properties. So a parallelogram means that it has two sets of parallel sides. So these two sides are parallel, and then these two sides are parallel. So it basically just means that both sets of sides are parallel to each other, and it doesn't have too many other properties. A rhombus means that it also has two sets of parallel sides. So it's the same as a parallelogram. However, all sides are equal. So those little tick marks mean that each of those sides are equal to each other. Okay? It looks just like a parallelogram, but all sides are equal. Okay? My drawing is not great. Okay? It kind of looks like the square. The square is different. The rhombus looks like a parallelogram. It just all sides are equal. A rectangle also has two sets of parallel sides. So it's the same thing as a parallelogram. These sides are parallel and these sides are parallel. Okay. However, rectangles have more important properties. The opposite sides are equal to each other. So the two long sides are equal and the two short sides are equal. Also, all angles are 90 degrees. So that means each angle is equal to 90 degrees, a right angle. And then a square is very, very, very specific and very important. It has all of these properties. Both sides are parallel, all sides are equal, and all angles are 90 degrees. So what you have to remember is a square is everything above it, not the kite and trapezoid. Remember, these are separate. A trapezoid is a quadrilateral, a kite is a quadrilateral, and that's it. But a square can be considered a rectangle. A square can be considered a rhombus. A square can also be considered a parallelogram. And a square can be considered a quadrilateral. So a square is all of them above it. A rectangle is not a square, and a rectangle is not a rhombus. But a rectangle is a parallelogram, and it is a quadrilateral. Same thing with a rhombus. A rhombus is not a square, and a rhombus is not a rectangle. But a rhombus is a parallelogram, and it is a quadrilateral. A parallelogram is nothing below it, but a parallelogram is a quadrilateral. Okay, this is super, super, super important. We need to know all of the proper properties of quadrilaterals. Okay, so this might be a point where you might want to stop this to help you with some of the problems on the Google form, because this you definitely need to know. Okay. Okay, next we're going to look at a word problem, and this one is a bit challenging. So that's why I'm going over one that's pretty similar to one that you're going to see on the Google form this week. So this says, my car had 1/4 of a tank left of gasoline. I drove around and used all of the gas that was left. I stopped to get gas and filled it to 2/3 of a tank. I did some errands and had 2/5 of a tank left when I got home. How much gas did I use in total? So again, this sounds a little wordy and it sounds like a lot of steps, but it's not too bad if we break it down a little bit. So let's go step by step. So my car had 1/4 of a tank left of gasoline, and I drove around and used all of it. So already I know I used 1/4 of a tank of gas. Okay. Next, I stopped to get gas and I filled it to 2/3. Okay, so now I'm gonna use a different color. Now I have 2/3 of a tank of gas. Okay, and I did some errands, and then when I got home, I realized I had 2/5 of a tank left. So I need to figure out how much I used while I was doing those errands so that I can add it to what I know I already used. I know I used 1/4, right? And then I know I filled it to 2/3, and when I came home, I had 2/5. So I need to figure out how much I used here so that I can add it with my 1/4. So what I actually have to do first is I have to take 2/3, because that's what I started with, and then I know I had 2/5 left. So I'm going to subtract to find out how much I used. So I need to do this step first before I can then add the two together to find out how much gas I used in total. Okay, so remember, total means addition, but we do have this extra step that I have to do because I did errands. When I did my errands, this is what I had left. So I need to figure out what I used, and then add it with what I know I already used in the beginning. Now, if you remember, when we add and subtract fractions, we need a least common denominator. So between 2/3 and 2/5, that's going to be 15. So you can either list out your multiples or you can multiply your denominators together. So I'm going to have times 5. What I do to the denominator, I must do to the numerator, times 3. I then get 10/15 minus 6/15. So I still have to do this first, and then I can add it with 1/4. So 10/15 minus 6/15 is 4/15, and then I need to add it with 1/4. I'm going to rewrite this over here so I have more room. I have 1/4 plus 4/15. So the 4/15 is what I used when I ran my errands. The 1/4 is what I did when I drove around and I used all the gas. Now I'm adding them together. But once again, I need a least common denominator. So between 4 and 15, that's a little harder. Those are a little bit bigger. Okay, so if I list my multiples of 15, I get to 60. So 15, 30, 45, 60. And 4, I can also get to 60 as well. So I'm actually just multiplying the denominators again. So I'm going to multiply by 15, and I'm going to multiply by 4. So I'm going to get 15/60ths plus 16/60ths to then get 31/60ths. So I use 31/60ths of a tank of gas for my entire trip. Okay, so again, this is a little wordy. It is a multi-step problem. But if you break it down and kind of pull out the important parts of the information, then it just becomes a simple adding and subtracting problem with fractions. Okay, sorry, that glare is a little hard to see, so maybe that would be a little bit better in case that glare was in your way. Okay, feel free to pause this video so that this can help you with one of your problems. Okay, the last problem we're going to look at is just some wording with division because I want to go over this with you. And I know this is something that we may have forgotten a little bit. So we have 5 divided by 8 and 7 divided by 3. So the easiest way to remember this when you put these into division problems is that we read left to right. Okay, so these numbers are going to stay really in the same exact spot. So 5 divided by 8 is going to become 5 divided by 8. And 7 divided by 3 is going to become 7 divided by 3. Now, if I wanted to write these as fractions, though, they're going to be very different fractions. Okay, so 5 divided by 8, remember, we read left to right. We also read from top to bottom. So 5 divided by 8 is going to turn into 5/8, and this just turns into a regular fraction. So 5 divided by 8 is the same thing as saying 5/8. This one, though, is going to be a little bit different. So 7 divided by 3 is actually, so remember, we read left to right. We also read top to bottom. So it's going to turn into 7/3. Okay, and 7/3 is fine. However, 7/3 is also an improper fraction. So we can leave it like this, but remember, it's more correct to technically turn it into a mixed number. So we can do that a couple ways. Some of you are pretty good at doing it in your head and know 3 goes into 7 2 times, okay? But if you forget, remember, we can always just do 7 divided by 3 on the side. So 3 goes into 7 twice. 2 times 3 is 6. Subtract, we get 1. And then we have to remember how to turn this into a correct mixed number. So 7/3 is going to be 2. So remember, your answer is always your whole number. The remainder is always the numerator, and your denominators never stay the same, or always stay the same, I'm sorry. So that should help you remember, or at least make sure you get the denominator correct. If it's 3 here, it's going to be 3 here. So then you just have to remember where the whole number goes and where the numerator goes. So your answer, 3 goes into 7 2 whole times, so that's your whole number. Your remainder is what's left, and that goes into the numerator. Okay, so those are your problems. Feel free to pause it whenever you need to help you with your Google form, but hopefully that helped you remember how to do some of those skills that we learned this year. And if you have any questions, don't hesitate to reach out or email or anything that you need to. And as always, your Google Hangout will be on Wednesday. So if you do have any questions, feel free to ask them during the Google Hangout. Okay, have a good day, guys.